morning, students. For today's session, we will discuss assignment number 6 of our CL8 lab. Assignment number 6 describes design sequence model for a given system using UML and implement a same using suitable object-oriented language. So for this assignment, we will discuss what exactly the sequence model is. We are going to describe the sequence diagram for a given system. We have already discussed the online grocery system. For the same, we will draw sequence diagram. The ELO for this is to design and implement a sequence model for a given system. We will discuss assignment number 6. Basically, sequence diagrams are deciding factor of how the events occur one after another in a sequence. So it is the interaction model between objects and how the message passing takes place between the different objects present in the system. These objects may be your actors described in use case diagram. So to start with the sequence diagram, we can consider online grocery shopping system. So what is the aim of sequence diagram? Identify at least 5 major scenarios, that is sequence flow of your system. Draw sequence diagram for every scenario by using advanced notation using UML 2.0. Implement these scenarios by taking reference of design model implementation using suitable object-oriented language. So in this system, we are implementing design model, that is the class diagram we have already implemented for online grocery system, and that implementations we have done with the Java object oriented language. For the same, we are implementing here the Java code and the sequence diagram. So what basically a sequence diagram? It is a form of interaction diagram which shows objects as lifelines running down the page, with their interaction over time represented as messages drawn as arrows from source lifeline to the target lifeline. Sequence diagrams are good at showing which object communicates with which other objects and what message triggers those communications. Sequence diagrams are not intended for showing complex procedural logic. What are the lifelines in the sequence diagram? Lifeline represents an individual participant in a sequence diagram. A lifeline will usually have a rectangle containing its object name. If its name is self, that indicates that the lifeline represents the classifier which owns the sequence diagram. Here, self, lifeline, and instance are given. So this dotted line indicates lifeline of the objects. It is connected with the rectangle which has the object name. Sometimes a sequence diagram will have a lifeline with an actor element symbol at its head. This is usually be the case if the sequence diagram is owned by a use case. Normally, boundary, control and entity elements from robustness diagrams can also own lifeline. So here, if use cases we are considering, then boundary classes, control classes, and entity classes having its own lifeline like actors. So if we are dividing what are our boundary classes, what are the control classes, and what are the exact entity classes, we can show the lifeline to these classes in a sequence diagram. What are the messages? So the messages are displayed as arrows. Always we write messages on arrows which are connecting to the lifelines of the object. Messages can be complete, lost or found, synchronous or asynchronous. It may be a call or a signal. The first message in a given diagram is synchronous message denoted by solid arrowhead, complete with an implicit return message. The second message is asynchronous, denoted by line arrowhead. And the third is asynchronous return message, denoted by dash line. Here, for showing the complete synchronous message, return equal to message parameter. With the solid arrowhead is the synchronous message. Second message is denoted by only line arrowhead. It is known as asynchronous message because there will be no return from that message. And asynchronous return message is denoted by the dash line. So these are the message types we need to show: synchronous, asynchronous type of the message communication between source and target objects. A found message is something which is a caller is not shown. Depending upon the context, this could mean that either the sender is not known or that is not important who is the sender. The arrow of the found message originated from a filled circle. So found message you will not get the sender object, only receiver object present. So denoting a sender, it indicates by the round filled circle. The exact sender is not known. Here found message parameters, arrow is indicated and receiver is receiving that message, but sender is not present. For asynchronous messages, the sender does not wait for the receiver to finish processing the message. It continues immediately. Messages sent to the receiver in another process or calls that the start a new thread are examples of asynchronous message. An open arrowhead is used to indicate that a message is sent asynchronously. So here we can check asynchronous type of messages where you get only line arrowhead. A small note on the use of asynchronous message. Once the message is received, both sender and receiver are working simultaneously. However, showing two simultaneous flow of control on one diagram is difficult. Usually authors only show one of them and show one after another. Then one more thing, message to self we need to show. So a message that an object sends itself can be shown like this. You can say show your object, then message to self parameter, return value. A message to self and its return value can show like a same message connecting to the object. So keep in mind that the purpose of sequence diagram is to show interaction between objects. So when you need to draw a sequence diagram, you need to think twice about every self message which you want to put on a diagram. The creation and a destruction gives you target that exists at the start of the interaction are placed at the top of the diagram and the targets that are created during the interaction are placed further down at the time of creation. So here in this particular diagram, we are having object shopping cart order. So here the shopping cart and order objects already exist when interaction starts. Then from shopping cart and order, add item. Then for order, there is a new and order line, that for order line object get created. And it is again connected to the order object. It is sending the asynchronous messages from order line to order and from order to shopping cart. And if I want to remove or destroy a particular order, then shopping cart passes remove O1 for order. It destroys the particular order line. And for destroying, you need to make this cross symbol, which indicates that the order line object is destroyed. And again, it is communicating to the order and shopping cart. So this is for showing how to destroy and how to create a object during the lifeline. A target's lifeline extends as long as the target exists. A target is destroyed during the interaction. Lifeline ends at that point with a big cross. So example of sequence diagram for online shopping. We have a customer, browse interface, UI, item database, purchase interface, checkout and credit card authorization. So from customer, the here synchronous message send browse items. From browse interface to the item, query item message sends. Then select items is one of the message between customer and a browse interface. After that, purchase message is from customer to purchase interface. Get selected items sent by purchase interface to the browse interface. Then query of the price information goes to the item database. Then display selected item, display price to the customer. Then for authorization, purchase from the purchase interface to the checkout. In authorization of credit card from the checkout to the credit card authorization object. Again, it's sending the asynchronous type of message to the purchase interface. Immediate notifications given from purchase interface to the customer. It sends the email from checkout to the customer. So this is the sequence of action for online shopping. So here another example for the hospital management system is given for your reference. So you can draw sequence diagram for the hospital management system. Consists of the patient, reception, doctor and account department, and you can mention the synchronous and asynchronous flow between the objects. So here we have analyzed the real-time system. Medical storage system is given. So for drawing the sequence diagram, we are again using the same system, that is online grocery shopping. As in my previous video, I have used the same system, online grocery, for drawing use case diagram, class diagram, activity diagram. So I am continuing with the same, that to draw sequence diagram for online grocery system using star UML. So we'll go to star UML directly. So just check, already we have saved our let's check. class environment, already we have created the online grocery system. We have generated our class diagram. This is your class diagram for online grocery shopping, activity diagram, use case diagram. Now to generate a new sequence diagram, to the top right corner here, online grocery system model we have already saved. You can right click on those models, say add diagram, and click on sequence diagram. You will get the sequence model symbols to the left side of the workspace, and you will get a workspace. To start drawing with the sequence diagram, first identify objects. You can give a name sequence diagram for online GS grocery shopping. Then identify the objects. How many objects you want in your system? So click on the objects, you will get object. Give the name of the object. As already you know, we have defined some of the objects like admin, then customer class. So for object, you can create number of objects, customer, then product, orders, can give all the objects name. Also shipping cart is in your one of the objects. Can delete if you get the multiple objects. Click on it, delete it from the model if you have multiple objects. Select object and you click on delete. Then if I want to show the interaction between the admin and the customer. So start with the from admin to the product. So you can select the message from admin to product, and the message name is add products, because when admin add the product, it will be visible to the customer. So add product. If you want shipping cart, you can just take, select this particular shipping cart and you can replace after order, but you need to show to the one after another the message passed. So from admin to the customer and to the product, you can show. After that, there is a message from product to the admin that add purchase. One after another, you need to select all, add purchase. After that, verification of product, you can put from admin to product, verify product. It's better to start with the verb verify products. Then update products. message from product to this is verified product, from product to admin. So after adding the products, if you think again, check from admin to product, that update product. So all operations which you are performing between the admin to the product class, you need to make one-to-one interaction. That is update products, then product updated, one-to-one interaction. Okay, so this is the communication between admin to product first. Then if you want to remove the product also or delete the product, you must specify that there is an operation of remove product. Then product get removed, you need to again place product remove. All the operations related to the admin products are listed here. After that, there will be a customer communication, that is, we need to check first that we need a self message to the customer that get registered, because to purchase online we have given the constraint that customer must have the login. After that, create again the self stimulus to the product itself, that self we need to put it here, that is login. After that, from customer to the product, we can select those products, that is, can create, can extend those lifelines to show the further communication. So from customer to the product, there is a message of selection. Select product. Okay. See here. After product selection, we need to make to the cart. So here we are having shipping cart, or you can check, you can add in the lifelines. Then you order object. So from customer to the order, you can say add to the cart. So this is the selection from the customer to the order, that add to cart. After that, view total, how many orders are there. So it is view total. After view total, if any discount is applicable, you can check for the discount. Then you can check for the shipping details, or choose shipping address. So it will be a connections between the customer and order. From this again you can select for the place order. One after another you can communicate. Place order. Then place order verification is sent to the admin. So this is our admin class and we need to check for the admin class after placing order from the customer to the order object. The communication between order and admin must take place, that is place order verification. Again from customer to the order can put a message make payment. Again payment verification from order to admin next page, that is payment verification. All type of message communications is can see here. One-to-one sequence wise message verification. After that return payment status. If user click on the return, sometimes return verification is also done. Return payment status. It may be sent from order to the admin. If it is not, then next is admin verify to the directly last is your shipping. So admin verify after payment, checking the status of delivery. So here contact to delivery from admin. Then from shipping to the admin, it gives you the invoke delivery option. After that, if return policy is there, can check here. It is return. Return shipping. Again, it is addressing to the admin. If customer invokes that return, replace or return order, again it is connected to the replace order. From again to the admin, it is connected and showing that it is return order. written on each order. For the customer class, after completing all the transactions, you can draw your self message to log out so that further actions will be stopped. So it is the generalized sequence diagram which shows the communication for online grocery shopping from admin to customer, customer to product, product to orders, all type of communication, and from admin to shipping or a delivery agents. So we can draw sequence diagram by using the star UML, and you have to remember that save all your diagrams under one model. Here I have created model as a online grocery system in which you can see here different diagrams like sequence, use case, activity, class, and we are collaborating with here all the type of a diagram. So this is related to your sequence diagram using star URL. How to draw sequence diagram.